Howdy y'all, how's it going? Today we're going to be doing a little bit more separable equations, but it's going to be with an initial value given. So let's work on this first problem. Y prime equals 1 minus 12x times y squared, where y of 0 equals negative 1 over 8. So we're just going to treat this like a standard separable equation, and then what we're going to do is when we get the value of c, we're going to use our initial value and plug it into that equation until we can find c. Once we find c, we go back and plug it into what our answer is with the c in it. With replacing this, whatever we get from this as c, you'll see. We'll see. So dy over dx, which is equal to y prime, equals 1 minus 12x times y squared. Right, so let's go ahead and divide this y squared over. So we're going to have 1 over y squared dy equals, and then we're going to multiply this dx over to get them separated. It's a separable equation. So 1 minus 12x dx, and then we can integrate both sides, correct? So the integral of 1 over y squared, or y to the negative second power, it's the same thing, is going to be negative y to the negative first power, right? So we're only worried about the c on the right side. So we have the integral of 1 is x, minus the integral of 12x is 6x squared, and then plus c, okay? So now we have our y value, our x value equals 0, our y value equals negative 1 over 8. So I'm going to go ahead and rewrite this, y to the negative first, as negative 1 over y to the, negative 1 over y, right? So basically when we end up plugging this in, we're going to plug in negative 1 over negative 1 over 8, which is just going to give us 8. Alright, so we can go ahead and erase this. We're going to call it 8. Actually, let's go ahead and just go down a step. 8. So 8, and then we're going to plug in 0 for x, right? So we're going to have 0 minus 0 plus c. So we know that c equals 8. So now that we know that c equals 8, let's solve this equation right here for y. So what we're going to do, we're going to multiply by y on each side, right? And then, so we'll have negative 1 equals x minus 6x squared, and we'll go ahead and plug in 8 is going to be c plus 8, right? And then that's multiplied all by y. And then we're going to divide everything by x minus x minus 6x squared plus 8, which will give us c. Yeah, okay. So I think the book has a little bit of a different answer. They're equal, but I'll show you what why the book's answer is this way. So we're going to divide everything. So we have negative 1 over negative 6x squared plus x plus 8. I'm going to write this a little bigger for you guys. So I'll have negative 1 over negative 6x squared plus x plus 8. And that was going to be our answer. The book has 1 over 6x squared minus x minus 8. So all that they're doing is just basically just factoring out a negative on the top and the bottom. So this is going to be equal to the answer of what the book says, which is just going to be 1 over 6x squared minus x minus 8. So they're going to be equal, this answer and this answer. So this is your answer, either one of these. And that's how you plug in an initial value to solve for C and get a more specific answer. So let's go ahead and do another one. So this one, y prime equals 3 minus 2x over y. Make sure you can see that pretty well. Yeah, okay. Y prime equals 3 minus 2x over y, where, you know, I'm going to do this in a different color. Y prime equals 3 minus 2x over y, with our initial value being, that's a semicolon by the way, I know my handwriting's a little sloppy, with our initial value being y of 1 equals negative 6. Okay, so we're going to have to pay attention to this negative sign right here in a little bit later. I'll show you what I'm talking about. So let's go ahead and solve the separable equation. So dy over dx equals 3 minus 2x over y. And then we're going to multiply both sides by y. So y dy equals, and then we're going to multiply both sides by dx. So 3 minus 2x dx. And then now we have everything on the left in terms of y, everything on the right in terms of x. So we can integrate now. So to integrate this, integrate y becomes 1/2 y squared. We're not worried about the plus c on the left side, remember? So the right side, we're going to say that the integral of 3 is 3x, and then the integral of negative 2x is negative x squared. And then we are worried about the c right here. So let's go ahead and multiply everything by 2. Y squared equals 6x minus 2x squared plus k, or 2c equals k, which being specific right there. So now what we can do is we can solve for k. And we're going to do that using this equation right here. We're going to say that x equals 1, y equals negative 6. Alright, so if x equals 1 and y equals negative 6, negative 6 squared is going to be 36 equals 6 times 1, which is 6, minus 2 times 1 squared, which is 2, plus k. So that is going to mean that k is going to equal to, well, subtract 6, add 2, which is going to be k equals 32. So now that we have that, we're going to pay attention, we're going to keep this equation, now that we have our k value, and we are going to rewrite it with the k included. So, and we're going to solve, I'm going to go ahead and square root everything, just solving a step further. So y equals plus or minus the square root, of negative 2x squared plus 6x plus 32. Now, do you think it's going to be the positive root or negative root? Or is it just going to be plus or minus? Well, our y value is -6, our initial value, so it's actually going to be just the negative root. So you gotta watch out for that in the initial value problems if you end up with a square root. And your y is going to be, it's a negative value to start off with, you're going to have a negative when you take the square root. So this is your answer. And let's do another one. Okay, so this one is already kind of set up for us. X dx plus y e to the negative x dy equals 0. So it's already split up. We don't have like a dy over dx or y prime or anything. They're already split into something. So let's just subtract one of them to the other side. Let's subtract this x dx to the other side. So we're left with y e to the negative x dy equals negative x dx. Now what we can do is we can divide both sides by e to the negative x. And when we're dividing by when we're dividing by e to the negative x, we're just doing the same as multiplying e to the positive x, because e to the x minus x equals e to the 0, which is just 1. So what we're doing is let's go ahead and, instead of dividing by e to the negative x, let's multiply by e to the x. Let's be a little bit more clean about it. So we have y dy equals negative x e to the x dx, right? So now that we have that, they're separated now, right? So you take the integral of both sides, and once you integrate both sides, you have 1/2 y squared equals, we're not worried about c on this side, the integral of negative x times e to the x dx. Well, we're going to have to use, can't really use substitution here because it would just be changing variables, so you'd have negative u e to the u, which just doesn't help you. You're going to have to use integration by parts. So we're going to set u equal to x because that is the power that we want to descend. And then dv equaling e to the negative e to the x, because there's still a negative. You could just pull the negative out. I like to do it this way because I can get lost, and it's just easier for me to do it this way. So now du equals dx, the derivative of u is just dx. The integral of dv is going to be also negative e to the x. So now, what is integration by parts say? It's uv minus the integral of v du. So uv, so negative x e to the x uv minus the integral of v du. So negative e to the x dx. Let's plug in all the right side values for this to get it to where we can integrate this. So now we can multiply everything by 2. Oh, I didn't do our initial value. Whoops. Our initial value is y of 0 equals 1. Okay, so now we can multiply everything by 2. So y squared equals negative 2x e to the x. I'm changing these two minuses to a plus, hope you agree with that. Plus 2 times the integral of e to the x is just e to the x. So it's just plus 2 e to the x. And then we plus c on the end, right? Because we just integrated that. So now we have y of 0 equals 1. So let's worry about that for a second. We're going to go ahead and solve for c here. We have 1, because our y value is 1. Our x value is 0, so this becomes 0, it goes away. This becomes, e to the 0 is just 1, becomes 2, and plus c. Subtract 2 from both sides, so c equals negative 1. Looks like an e, but that is a c. Okay, so our c value equals negative 1. So I'm just going to go like that. And then we are going to keep solving. All there is really left to do is just take the square root, right? So let's do that. And let's see which square root we're going to have to take based upon our values. So y equals the square root of negative 2x e to the x plus 2 e to the x minus 1. It's not going to be plus or minus because it is, our y value is positive. So we're just going to, it's not going to be plus or minus, it's the positive root. This is the answer. I know the book, it looks a little different. I'll show you how they got that answer. They're equivalent. Theirs is just a little more simplified. So how they factored that out in the book is just plot a 2 e to the x, and then you have 1 minus x, and then minus 1. Yeah. So this is going to be your answer. So this is going to be your answer right here. So I'm going to come back and do 3 more problems, and then we'll probably be done with separable equations. So I've got 3 more problems for you for these initial value problems in separable equations. So we got y prime equals 3x over y plus x squared times y. And our initial value is y of 0 equals negative 7. Keep in mind that negative, just in case there's a square root or something. So what we're going to do is we're going to change this to dy over dx and start to make it separable. Okay, so now let's go ahead and factor out the y out of this this denominator right here. Okay, so now we can go ahead and multiply the y over and multiply the dx over. So what we have is y dy equals 3x over 1 plus x squared dx. So this always kind of confused me in calculus 2 for a little bit because I didn't really see the big picture, but I was like, oh yeah, 1 over x squared, that's all automatically going to be arctangent. Well, no, that's not true. We can use a u substitution right here, and we'll do that in order to get our answer. So we're going to integrate both sides. So we have 1 over 2y squared here. We're not worried about the c on the left again. Here we're going to use a u sub. So u equals 1 plus x squared. Du equals 2x dx. Dx equals du over 2x. Just dividing by, so we're taking the derivative here. Then we're solving for dx. Divided by 2x. So now we have, I'll go ahead and rewrite the integral. So we have 3x over u, and then dx is equal to du over 2x. So the x's cancel, and you're left with the 3 over 2 out front. Because we can pull out constants while we're integrating. So I'm going to go ahead and copy this down up here. Make it a little bit nicer. So 1 over 2 y squared equals 3 over 2 times the integral of 1 over u du. So now the integral of 1 over u du is going to be the natural log of u, right? Well, our u is 1 plus x squared. So 1/2 y squared equals 3 over 2 times the natural log of the absolute value. Well, here we don't really have to use the absolute value because 1 plus x squared, no matter what the value of x is, it's always going to be valid because it's always going to be 1 or greater. So, or it's always going to be, it's always going to be greater than 0. So 1 plus x squared, so natural log of 1 plus x squared, and then plus c, right? Because we have to Keep in mind the constant of integration. So now that we have all of this, we can use our initial value and solve for c. Okay, so we know that y equals negative 7, x equals 0. So let's start plugging stuff in. First, let's get rid of this. Let's multiply everything by 2 to get rid of this 1/2 because it's kind of ugly. So y squared equals 3 natural log of 1 plus x squared plus 2c, which is just going to be k. So here we're solving for k, and we're using this equation. So y squared negative 7 squared is 49 equals 3 times the natural log of 1, right? Because x is 0, so this is going to be the natural log of 1 plus k. Natural log of 1 is 0, so it looks like k is going to equal 49. So now let's take the square root of both sides of this. So we're going to have y equals plus or minus, and if you're ahead of me, bear with me, 3 ln 1 plus x squared plus 49. Now, is it going to be the positive or is it going to be the negative root? It's going to be the negative root because of this initial value. So we're not interested in the positive root. This is going to be our answer. Let me make sure I'm right. Yep. Okay. Cool. So this is our answer. Let's do 2 more, and then we can move on to something else. Okay, our next problem is going to be, just prepped a little bit. Okay. Okay, so our next problem is going to be y prime equals 2x y squared plus 4 x cubed y squared, where our initial value is going to be y of 1 equaling negative 2. Did I copy that down right? Okay. So now we can figure out what we can factor out, what each term has in common to make them separable. If they didn't have the same power like they do the y squared, you see how they have the same y squared, I don't think it would be separable. So it's a good thing that there's a y squared there twice, because we can work with that. So we're going to factor out a y squared. We're left with 2x plus 4x cubed. And it's starting to become separable, you can see, because there's a way we can separate this. So we're going to have 1 over y squared equals, 1 over y squared dy, because we are dividing both sides by the y squared. And we're keeping dy on this side. Equals, and then we're going to multiply the dx over. 2x plus 4x cubed dx. So now what we can do is we can integrate both sides, and the integral of y to the negative second power is going to be, well, 1 over n plus 1, right? So 1 over n, which is negative 2, plus 1, which is negative 1, and then you're going to add 1 to this negative 2, so that's going to be negative y to the negative first. And just to check it, you can go ahead and take the derivative, and you're going to get y to the negative 2, which is what we have right here. So negative y to the negative first power, we're not worried about the plus c over here again, only worried about on this side, equals the integral of 2x, which is just x squared, plus x to the fourth. The integral of this is x to the fourth, and then plus our constant of integration c. Now once we have that, what we can do is we can plug in our initial value. y of 1 equals negative 2. So what we're going to do is, I'm going to rewrite this as 1 over y, negative 1 over y for now. Makes it a little bit easier to see for you. So our y is negative 2, so we have negative 1 over negative 2, okay, equals 1 squared plus 1 to the 4th plus c. So we have positive 1/2 equaling 2 plus c. So c is going to equal, let's see, this is 1 over 2 minus 4 over 2, which is going to be negative 3 over 2. So our c equals negative 3 over 2. I'm going to write that up here. And then I'm going to erase this, copy this up here, and we can actually, I don't have enough room to do this. We can go ahead and solve this now for y with our c value put in. So we're going to take c equals negative 3 over 2. So now what we're going to do is multiply everything by y. And that's going to give us negative 1 equals this basically, and then we're going to divide everything by this. So here, I'll go ahead and write it out. So and then we're going to divide by this. So what we wind up with is y equals negative 1 over x squared plus x to the 4th minus 3 over 2. And I think the book, again, is a little different, but I'll show you why. Basically, they're taking this negative up here and distributing it down here, I think. Yeah, that's what it looks like. Oh, I think it's a plus, actually. Whoops, I messed that up. Sorry. Just a little sign error. Okay. So yeah, what they did was they distribute this negative from the numerator and into the denominator. So y equals 1 over negative x to the 4th minus x squared minus 3 over 2, and that's going to be your answer. So dy over dx equals 1 plus y squared times the tangent of 2x, where y of 0 equals negative root 3. So it's close to separable already, right? We have 1 plus y squared, so let's just divide that over and then multiply dx over. So we're left with 1 over 1 plus y squared dy equals tangent of 2x dx. And now it's separable, right? So let's just integrate both sides. We know that this is a trig identity. This is going to be the arctangent. The integral of this is going to be the arctangent of y. So arctangent of y equals the integral of tangent of 2x. We're going to have to, I mean, I guess you could, so you're going to have to use a u sub. U equals 2x, du equals 2 dx. Dx equals du over 2. So this is going to become the integral of 1/2 tangent of u du. And this is another identity. It's a little obscure, but it's not that bad. I'm not going to prove it. But you can look it up. Arctangent of y is going to equal to the integral of 1/2 tangent of u is going to be negative 1/2 ln of the absolute value of cosine of u plus c. So u is 2x, so we're going to go and throw that in there. So arctan y equals negative 1/2 ln absolute value cosine 2x plus c. And then we're going to come up here and we're going to solve for y. So over, because I think it's a little bit easier. I mean, I guess you could plug in this stuff right now, but I think in my opinion it's a little bit easier to solve for y first. It's really up to you, it doesn't matter. So arctangent of y, let me make sure that you can see this. Yeah, okay. So arctangent of y equals negative 1/2 times the natural log of cosine of 2x plus c. So what is the inverse of arctangent? It's going to be tangent, right? So let's take the tangent of both sides. So when you take the tangent of this side, it's a little sloppy, tangent of both sides, you're going to undo this function right here, leaving you with just y. And then here we have the tangent of negative 1/2 natural log absolute value of cosine of 2x. Oops. Absolute value of cosine of 2x plus c. We don't have our c value yet, that's why we got into this form, because I feel like it's probably a little bit easier to plug in initial values when you have like just a value of y, so like I'm calculating. I mean, you're gonna have to do a little bit of work anyway, but we'll see. So negative root 3, because y equals negative root 3, and then y is 0, or x is 0, equals the tangent of negative 1/2. Well, the natural log of the cosine of 2 times 0. Well, 2 times 0 is going to be cosine of 0, right? Which cosine of 0 is 1. So the natural log, actually, in this function is just going to go away, because you're going to have negative 1/2 times the natural log of 1, which is just 0. So 0, and then, oops. Zero plus c, which is just, I just wrote that because you know that this is 0 and we have c still. Sorry, I forgot this in parentheses. So I'm just going to go ahead and erase this. That was just to notify you that you know that that's 0. So the tangent of c. So now we can solve this by taking the arctangent of both sides, right? So arctangent of negative root 3 equals arctangent of tangent, which is going to be c. So let's do that real quick. Arctangent of negative root 3. And that is going to look like, it's negative pi over 3. Yep, negative pi over 3. So c equals negative pi over 3. So what our answer is going to be is, I'm going to go ahead and erase this, write the answer right below. If I'm erasing stuff too much from my videos, just let me know and I won't do it anymore. I just like to have it like clean. I would just assume that you guys are like pausing the video and working along. So now that we have c equals negative pi over 3, we can plug it into our answer, which this is our answer right here. Y equals tangent of negative 1 over 2 natural log absolute value cosine of 2x. Let me get this over here. Okay. Minus pi over 3, right? Okay. So again, this is the right answer. In the book, it's a little different. What the book says, it's a negative tangent of 1/2 natural log of cosine of 2x minus pi over 3. So we know that tangent is an odd function, which means like sine is an odd function, right? So sine of negative x equals negative sine of x, right? Cosine's an even function. Cosine of negative x equals cosine of x. You can just delete the negative, right? This is an even function, this is an odd function. An odd function, they factor out the negative and the negative comes out front. And that's what they did to get the answer in the book. So y equals negative tangent 1 over 2 natural log cosine to absolute value of cosine of 2x minus pi over 3. Alright, so that is going to be all inseparable equations and initial values. I'm not too sure what's next, but stay tuned. Thanks.